Some answers to worksheet number 12, questions 5 to 9, which was your homework last night. For question number 5, we get 7.01 meters per second squared. The acceleration, 3 significant digits there. For number 6, we got 1.3 meters per second squared. Again, 2 significant figures this time. 7, we got 4.9 meters per second squared, 2 significant figures again. 8, we got 29 newtons. 2 significant figures. And question number 9, we got 4.9 meters per second squared. Once again, 2 significant figures. Let's take a look at questions 7 and 8 then. We want to find the acceleration in question 7, and we want to find the force of friction in question 8. The thing to do here, or at least my suggestion to do, is to redraw this diagram. Turn it into like a one-dimensional thing. Put it on one plane so that everything is going on one axis, the x-axis. So what I want you to do that is to take the 6 kilogram object, kind of twist it up like this, right? If we do that, and we redraw the diagram so that we twist up that 6 kilogram object, it's going to be on a flat plane. It's not really on a flat plane, but we're pretending that it is on a flat plane. And gravity would act this way. We're going to call this object 1, object 2. We're going to call this FG2. What's the value of FG2? Is it 2 times 9.81, 6 times 9.81, or 8 times 9.81? The force of gravity acting on the 6 kilogram object, right? Yeah, it's 6 times 9.81. We'll deal with that in a few minutes, but yeah, it is 6 times 9.81 meters per second squared. 6 because the gravity is pulling on the 6 kilogram object. Now, we also have a force of friction acting here. Which way is friction acting? It doesn't tell us. Yeah, it's going to act to the left. It's acting directly on the 2 kilogram object, but it doesn't really matter about that. It doesn't really matter where I label it. It's 20 newtons to the left. Now, we also do technically have a normal force and a force of gravity acting on the 2 kilogram object, right? But why am I not so worried about those? They cancel, right? Nothing cancels with FG2 because the 6 kilogram object isn't on a table, but the 2 kilogram object is on the table. So just like the desk sitting on the floor here right now, gravity pulls down on it and the table pushes up on it to balance that out. So a lot of times in these questions, because they get a little bit more complicated, I don't even draw those in. We just assume that they're canceling out. All right, there we go. Now it's the same as any other problem, right? Now we say the net force is equal to the sum of the forces, which we're going to say is FF plus FG2. Then we say M times A is equal to the sum of those forces. M is, what mass do we use? 2, 6, 8, 4, the difference between the two of them? Daniel, which mass am I going to use? 2, 6, 8, or 4? 8. It is 8. It's the total mass. And the reason we use the total mass is because the net force, that's what we're looking at right there, right? The left side, the net force acts on the whole system, not just on one object, but on the whole system. So we're going to use the mass of the whole system. The force of friction, we're going to make negative 20 newtons because it is to the left. In FG2, we're going to make, what was it again? 2, 4, 6, or 8 times 9.81? Max, you remember that? Which mass are we going to use for the force of gravity here? 2, 4, 6, or 8? Yes. Yeah, it's 6 times 9.81. Why is it 8 here and 6 here? Well, again, 8, when we say M times A, that's the net force. And the net force acts on 8 kilograms, the whole thing. But the 6 Newton, or the gravity, is acting only directly on the 6 kilogram object. So that's why we're using 6 there as opposed to 8 there. In the end, we're not going to use 8 times 9.81 because the 2 times 9.81 we showed you canceled out with the normal force, right? So there's only 6 times 9.81 left. Yeah. All right. I got that drawn as positive. Shouldn't gravity be negative? Shouldn't gravity be negative? Yeah, not in this case because we've drawn it to the right. And this is This is why we draw it like this, to the right and to the left, so that we're a little bit more clear on what should be positive and what should be negative. If we draw it on this diagram, on the original diagram, we've got a force to the left and we've got a force downward, and we think that both of them should be negative. But of course, since they oppose each other, one of them's got to be positive. It makes sense to make gravity positive here. So we're going to say 8 kilograms times the acceleration equals 6 times 9.81, I believe is 58.86. Is that right? Subtract 20 is 38.86. And I do know this one. I have the answer written down for this. 38.86 divided by 8 is 4.9. 4.9, that's what I have written down at least. 4.9 meters per second squared. Hey, listen, it's less than 9.81 meters per second squared. Should it be? Yeah, if you had a 6 kilogram object that was just hanging there and you cut the rope and it fell, it would accelerate downward at 9.81. But it's being pulled back by friction. In addition to that, you have a force of gravity of 58.86, 6 times 9.81, but that force of gravity doesn't just have to pull the 6 kilogram, that force of gravity has to pull 8 kilograms. So even if there is no friction, the acceleration is going to be higher than it is right now, but it's still, if there's no friction, going to be less than 9.81 meters per second squared. Is that okay? All right, question number 8 says, what's the force of friction acting here? Let's straighten this one out too. Okay, let's pull the 5 kilogram up like this. If we do that, then we're going to pretend the 5 kilogram is on a flat surface, connected to a 3 kilogram object, which is already on the flat surface, connected to a, well, if we pull the 12 up like this, it's connected to a 12 kilogram object right there. Now there's a force of gravity pulling on the 5 kilogram object, right? This way. I'm going to call this FG1. And there's a force of gravity acting on the 12 kilogram object. It's going to be bigger or smaller, same size? Bigger or smaller, same size? Gravity acts on the 5 times 9.81. Gravity acts on the 12 at 12 times 9.81. So it's going to be a bigger force, right? We're going to call that FG3. Now, which way is friction going to act? We're finding the force of friction. So actually, because we're solving for it, and we draw the diagram, and if we guess wrong, we're actually okay, because mathematically we'll solve for it, including the direction. But we're still going to draw it. We're going to guess the direction, make an educated guess as to the direction. Which way is it going to be? Yeah, it is going to be to the left, right? We know it's going to be to the left because it's going to move to the right. Now, remember, there is that normal force and force of gravity acting on the 3 kilogram object that cancel out. I'm just going to skip that because we got a lot of stuff going on in this diagram already. Next step, step number 2, F net is equal to the sum of the forces. We're going to say FG1 plus FF plus FG3. Remember, there is an FG2, but again, it cancels out with the normal force on object number 2. The net force is M times A. Same forces adding together there. What mass do I use? 5, 3, 12, 19, 8, 20, I guess it would be, or some sort of combination of them. Which mass? Gabe, which mass am I going to use there? 5 and the 12, so 17. Yeah, you are going to use all 3 of them, okay? So the total mass here is going to be 20 kilograms. You're going to use all 3 of them because the net force, the total force, acts on the whole thing, all 20 kilograms of it. So that left side of the equation is always going to be the total mass. The acceleration is 2.0 meters per second squared. It is to the right. We know that, so we're going to make it positive. FG1 is, what is that, 5 times 9.81, 3 times 9.81, 12, combination of those. Jack, what mass are we going to use for M times G here for FG1?
You're going to use 5.
Good, 5 times 9.81. Plus the force of friction, That's what we're solving for here. Plus, that's going to be 12 times 9.81, right? Now, I just went through and didn't even worry about signs, positives, negatives. Is there anything that I have to make negative here? Tyler, is there anything that I have to make negative? Yeah, you can put the negative with the 9.81 there. That's fine. Or you can put the negative in front of the term. That's fine. It doesn't really matter where it goes as long as it goes with that first term. Okay? So we're going to say 20 times 2 on the left-hand side is 40. 5 times 9.81 is negative 49.05 plus FF plus 12 times 9.81. I'm not sure what that is in my head. 117.72 newtons. Now, let's combine those terms on the right-hand side. 117 subtract 49 gives us, so we get 40 on the left-hand side, 68.67 plus FF. Now we're going to take the 68.67 over by subtracting. That's an easy one. 40 minus 68.67 gives us negative 28.67 newtons. There's our force of friction. It's a negative value, as it should be, right? We predicted it would be to the left because it's moving to the right. We got a negative value. Now, how many digits should that be? How many significant figures should that be? Yeah, that's 2, yeah. Look at our data here. 2 digits, 2 digits, 2 digits throughout, right? So final answer is 2 digits. What are we going to round that to if it's 2 significant digits? Christian, what is that, 28 or 29? Yeah, so we look at the 2 digits, then we look at the one right after it. It's a 6. So the other one's round up, right? That becomes a 29 newtons, negative 29 newtons. Good? How many people got that? Excellent. Here's a question that could serve as a little practice quiz for tomorrow. We've got 4 objects this time. Let's number them so that we're all consistent when we're solving this. 1, 2, 3, and 4. We've got a force of friction acting of 25 newtons. Doesn't say which way. We're going to find the acceleration of this. We'll give you a few minutes to work on that at your desk here now. So this one's got 4 masses. First time we've seen that. It doesn't make it that much harder, but there is one little thing that could lead us to a mistake here. If we really understand it, though, we're gonna get past that. All right. Let's straighten it out here. Let's take the object number 1 and let's pull it up like this. If we do that, then object number 1 will be on a flat surface here. Okay, and it's going to have a force of gravity pulling on it like this. Of course, it's not really pulling on it like this, but we're going to show it pulling to the left there. And we've got a 10 kilogram object right here. And then if we stretch out the other side, we've got a 7 and a 3 kilogram object also on the horizontal surface like this. Now, which way is it going to move? Which way is it going to move, right or left? Colton, which way is it going to go, right or left? Yeah, because that force to the right is going to be bigger, right? The 3 and the 7 combined are much bigger than the 5, right? So it's going to go to the right. That means friction is going to act to the left. We'll draw friction to the left here. There is a normal force and a force of gravity acting on the object number 2 as well, but they cancel each other out, so we're not going to worry about that. Now, what force do we have acting to the right? You could do this in one of 2 ways. You could keep them separate and say there's a force of gravity 3 and a force of gravity 4. It's not just object number 4. Gravity is acting on 3 as well as 4. Does that make sense? We need the 10 kilograms, the total 10 kilograms for the force of gravity there. So what I'm going to do is just draw a force to the right. I'm going to call it F34, FG34. Not FG3 or FG4. I'm just going to combine them. I could make it FG3 and FG4 separate and then add them up. I'm just going to combine them because treat it as one mass here. So let's say F net is equal to the sum of the forces. FG1 plus FF plus FG34. How many people combined those 2 masses and did something similar to what I'm doing, FG34? Yeah. How many people made them separate, FG3, FG4? It's going to give you the same answer, right? So it doesn't make any difference there. The net force is m times a. We're looking for the acceleration here. The mass we're going to use is the total mass, right? 3 plus 7 is 10, plus 10 is 20, plus 5 is 25. 25 times the acceleration. FG1 is going to be 5 times 9.81. But we're going to make that negative because it's to the left. Friction is going to be 25 newtons. We're going to make that negative as well because it's to the left. And we're going to say FG34 is going to be 10 kilograms times 9.81. Some of you would have had 3 kilograms times 9.81 plus 7 times 9.81. Same thing. So this is going to be 49.05 right there, 98.1. Subtract the 2, 49.05. Subtract 25, 24.05 on the right side. 24.05 newtons. The A is going to be 24.05 divided by 25. What is that, like 0.9 or something like that? 0.9 something? Should be 0.96. 0.96 meters per second squared. It's a positive value, which means it accelerates to the right, which we've expected it to accelerate to the right, right? Because the force to the right is bigger than the force to the left.